Streets, and this is my partner Emma Horning. We did rates of chemical reactions. The objective of this was to obtain a rate law and calculate the rate constant for a reaction. The rate law is determined by measuring the time it takes for the purple color of KMnO4 to disappear. The experiment was repeated 3 times at 23 degrees Celsius using different amounts of the 0.13 stock solution and KMnO4 and 0.75 of the oxyl acid. These are our conclusions. 6 test tubes and a stopwatch were obtained. The spec 20 was turned on and the wavelength was set at 565 nanometers in the transmittance mode. Concentrations of each solution are recorded in table 2, which is on the next slide. The temperature was also recorded. This is table 1. These are our solutions that we made. The oxyl acid concentration was 0.755, the KMnO4 was 0.13, and the room temperature was 23 degrees Celsius. Using a burette, 5 milliliters of oxyl acid was put into a test tube, and then 6 milliliters of distilled water was added to that same test tube using a burette. The professor then gave assistance to transfer 1 milliliter of the KMnO4 into a test tube and mixed. The timer was then started. The contents were transferred into a cuvette and put in a spec 20. The timer continued until the percent of transmittance passes 30%. The steps were repeated in experiment 1 until 2 of the time measurements differed by 10 seconds, less than 10 seconds. The steps were then repeated for experiment 2 and 3. This is table 2, which was our reaction time. It recorded the time it took for the solutions prepared to reach and pass 30% on the spec 20. The trials were repeated until the times differed by less than 10 seconds.
This is table 3, the rate and rate constant. And to find the molarity of the oxalic acid and the KMnO4, we use the equation M1 times V1 equals M2 times V2. So for experiment 1, 0.755 molarity and 5 milliliters and 12 milliliters were all given. So we just used that equation to find that it was 0.315. And then for the average reaction time, we just added up all of the reaction times from each trial and found the average time. And then to find the rate, we used rate equals K times, for the rate, we divided the molarity of KMnO4 by the average reaction time, and that's the first column. And the second column for the rate constant, we use the rate law, which is rate equals K times the molarity of KMnO4, X times the molarity of oxalic acid. Right there, those are for the second column. And for the average K, we just average the K. And then for the kinetic order, to find the rate constant K, we substitute the molarity values of oxalic acid and KMnO4 into the rate law equation and set it equal to the rate found earlier. And those are our sample calculations for the table. And for discussion. To determine the rate law of the reaction, we use the initial rate method, rate equals K times the molarity of KMnO4, X times the molarity of oxalic acid, Y. And we found the initial molarity of KMnO4 using M1 times V1 equals M2 times V2 with the predetermined numbers for M1, V1, and V2, which is right there. And then we solved for the rate by dividing the molarity of KMnO4 by the average reaction time. And then the next step was to find the order of the reaction, and this was done by holding the concentrations that are the same constant. And everything else cancels, leaving us able to solve for X and Y. We then could substitute all these numbers into the rate law equation.